Hello, everyone, and welcome to today's SANS webcast, Scoping an Intrusion Using Identity, Host, and Network Indicators, sponsored by Vectra. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speakers are Chris Crowley, Senior SANS Instructor and Course Author, and Dale O'Grady, Principal Engineer at Vectra. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to our presenters.
Great. Thank you very much for that, Carol. Appreciate the opportunity to talk about this. As Carol said, I'm a senior SANS instructor and I've written a number of courses. And Dale is principal engineer at Vectra. So I'm going to be going first, talk a little bit about the paper that is the first part of this series. And then I'll get into a little bit about this paper and have a few explanations about some of the things we discuss in this particular paper. And then Dale is going to spend some time talking about the technical ways that Vectra would implement the things that I'm discussing. So I want to start off with a discussion just briefly of what we talked about on the previous webcast and what's written in the first paper. So in the first paper, we talked about hunting for initial discovery. The idea being that your alerting systems didn't alert you for any number of reasons, and you still want to make sure that you're identifying all the problems that are in the network. So what we can do is look for things that are very infrequent, so we call this least frequency of occurrence, or very frequent. If there's something that's taken over your network, you're going to see lots and lots of it. So you can use frequency of occurrence as a differentiator in order to identify something that you're potentially interested in investigating. You can also, and as I'm listing these, and we talked about this in greater detail in the first webcast, you can combine these in different ways, but you can also do it based on timing. So novelty, meaning the first time that we saw something that operates in a predictable way, tends to be automated. That might be an indicator that it's something that's maybe not what you want happening in your environment. And then you can also have a very long scope. And so if you see the repetition over weeks and months, that might be interesting as well. We talked about anomalies, the idea of nonconformance to protocols or to various things which are typically seen in network communication. The network that it's connecting to in terms of the IP address is different, or maybe the IP address is geolocated to a specific region that you don't interact with frequently. That might be an outlier worth investigating. So these sorts of things are what we talked about. And the last one was using mathematical analysis in order to attempt to identify the item as an outlier. So that was what we talked about in the first paper. All of these techniques are still valid and worthwhile where we're looking here. So you can use these things when we're talking about scoping and intrusion after you've detected it. And so this paper and this talk is intended to encourage you and really give you some specific techniques to do this, where after you have found that there is a problem, part of what you must do is to identify throughout your environment where the entirety of this problem has gotten to. And so I'm going to talk about two different scenarios. These two scenarios are very common compromise scenarios. The first one is a beaconing device, something which has been compromised and is connecting out and is doing something. The second one is the idea of once that attack happens, usually that's not the end of the attack. After the attacker has gotten in, after they have gotten command and control over a system, after they have gotten whatever they can get from that one position, they're going to look to move from within your environment to other things. And the second scenario actually is a pretty challenging one. When I talk about it, you will probably think, or I'm hoping you'll think, could we do this? How would I investigate something like either of these scenarios? But I think the second scenario is a little bit less common. It's a real challenge. And so What I want to do is point out both of these scenarios, talk about things which I would want you to do in your environment should something like this happen. And then again, afterwards, Dale is going to then go into and show specifically on Vectra how they would do those investigations. So the entirety of today, the presumption is the compromise has already happened. You have already detected the compromise, and now you're attempting to determine the full scope. So the thing that I have as a prevailing thought when I talk about this, and I try to use analogies to make sure that people really comprehend this, is this is not a lone actor. If there's an intrusion, right, don't think about that intrusion as a singular actor. Think about it as there is a thrust to break into your environment, and whatever this attacker is actually looking for other places to spread out to. And so if you want to think about this as like insects making a nest, right? I mean, it's like if you find an ant in your kitchen, it's probably not the only ant that's there. And so what you want to do is figure out how that thing is getting in and figure out the path that it used and where it has gone so that you can then pivot around and look for all of the other intruders in the environment. Now, a mistake that I think that a lot of people make is when they say that they've contained something, or they say that they've eradicated something, they say it with respect to the thing that they know is an intrusion, as opposed to saying it with respect to the fact that they have derived indicators of an intrusion and then looked everywhere in their environment for those indicators, right? And being skeptical of the singular indicator being enough to say, oh yeah, well, that attacker's been on that host. Because guess what? We're talking about not ants or predictable things. We're talking about human beings who are motivated to do something. And they can change and adapt their behavior. And they know that we as defenders are overburdened and we have too much stuff to do. And if we can get to the point where we can say we're done, we'll probably just stop there, as opposed to us taking all of the details that we have and doing extra work to make sure that the adversary is gone. And they will take advantage of that. Okay? So I'm going to talk about that. All right, the first scenario. First scenario is when a suspected host has basically initially been identified. And in this case, let's just presume it's a high-frequency beacon. So this beacon was going out to a specific server. We hadn't seen that server before. That domain wasn't one that we typically communicated with. So that that initial detection happened. So after the detection, we did some containment. And we did some initial forensic analysis on the host in order to assess how this attacker got in. The attacker got in using a well-crafted phishing message. Okay, so this was one that was targeted. It doesn't really matter. You've seen this before. It could be any number of things, but a human being in our environment thought that the message was to them for some reason. They clicked on the link, they opened the attachment had an executable in it, and at that point, this is what we know of this intrusion. Okay? So we've done enough forensics to see what this situation is. Right? We've caught them, but now what we need to do is say, okay, was this the only phishing email message that was sent in? In order to make that determination, what we should do is look at the domain which was used for the beaconing. This is an initial thing. It's an attribute of the command and control connection. The domain that was used for the beaconing, we can then look to see if any other systems have connected to that. We want to also look at the domain that was used in the initial email in order to either have the URL that was basically the person was going to click on. If there was any sort of second stage download of an executable, we want to look at that domain and see if that's actually something that's been contacted by other hosts in the environment. So as we're extracting these different domains, we're going to then go look through all of the resources that we have in order to be able to determine if anything else in our environment has communicated with that. So we can basically look at the remote access Trojan itself, and we can do some analysis of that to see if there was something that was different that maybe based on where it landed, it made some differentiation. We may need to use threat intelligence in order to do this differentiation to see if there was targeting specific to us. We also can extract other details out of the network, such as the SMTP server sending the original email. Once we have that SMTP server, we can then basically go ahead and say, all right, this was what transferred the message in. Let's look to see if that SMTP server sent any different messages. And all of those then become suspect and warrant further investigation. In terms of the domain or the link, if there was one that was using the phishing email, what we want to do is extract a schema from that. How does this thing break down? Not just the literal domain name, but are they using 4 or 5 different words concatenated together? Maybe look for things like in the URL that's present, a syntax or a sort of a presence of specific variables that we could then take and extract those variables and look to see if those URLs are present in other requests that were going out from our network. You can't have like a very concise match all the time. And so what you're looking to do is extract elements that are providing you with essentially fuzzy matching, where it's good enough to say, yeah, this one's similar to the one that actually got in initially. We could use our DNS queries that were made by the host that was compromised and look to see if other hosts have made the same DNS queries, presuming you have query logging enabled in your network. And additionally, we can look at all of our network devices, the router, the firewall, any other sorts of network devices which are present, which would allow us to extract information to see if that same IP address was requested. In addition to the network details, or actually, let me first say where we can get some of these things. So the host that was compromised, we could actually extract memory, do a memory analysis of this, and see what sort of information is embedded in that application that was doing the command and control in order to extract all of the different places that it might be able to communicate to. There are some times where it will be pre-programmed to be able to connect to multiple different locations, and it selects only one of them. So we might be able to find different hosts out of the code that's in memory itself. We can also, on the host that was compromised, look at things like the DNS cache. If we've responded very quickly, we can look at that. We can look for network connections, and one thing that I would suggest that you consider is if there is IPv6 able to go out of your network, make sure that you're also looking for IPv6 connections. This is something that it's there, it's present. There might be tunneling that's in place where you're doing IPv6 over IPv4, and things are not readily apparent in terms of what the host is actually doing to you. The attackers are not going to make it easy. We can also look to see if you have logging on the host, what executables happened when the attacker is doing what is often called live off the land. And so there are a lot of things that an attacker can do once they get onto the host initially to use native executables to do work in order to accomplish whatever their objectives are. And this might be spreading out, as we'll talk about in the next scenario, but it might also be sending files out, and they actually are using an executable that's present on your host. So you can basically look through the tracking of actions that are present from log entries on the host in order to try to see a pattern of behavior, and then that pattern of behavior might allow you to then look on other hosts to see if that thing was performed as well in that same pattern. The web browsers actually have a lot of interesting details in them as well. So you may be able to get browser logs and browser cache and see stuff out of that allows you to understand what the attacker was doing off of the host. And of course, all of your endpoint protections, and I've got a string of acronyms there that basically reflects the the partition of different vendor technology, malware protection, XDR, endpoint detection, protection and response, and so on, whatever it's called. These usually have incredible instrumentation on the host that you can extract information from in order to track out historically what an attacker did in order to really get those details. So things that we actually then use from those details of what the attacker did on the host in order to pivot to see what actually else happened in our network that looks a lot like that. Obviously, if they use the exact same domain as for their command and control on multiple hosts, you should be able to find that trivially easily. But you want to also look for shifts in what they're doing. So if they compromise initially over IPv4, and then they actually do some sort of movement in terms of going to other hosts internally, they're not limited by IPv4 if they can talk to other hosts internally over IP6. So you can look for, from that host, anything that's an IP6 communication. You can look for IP addresses changing on a domain. So it may be that when you first discovered this, the IP address in use was what was resolving at that time. But that resolution could have been different previously. And so you could be looking for a specific IP address now, but they were using a different IP address previously, and another host in your network will use that previous IP address, and maybe even continues to use that IP address. And they're doing some sort of DNS cycling where on a per host connection basis, they're actually changing the IP address of what that's resolving to. In addition to that, attackers love to use cloud resources because you tend to need to, from a defensive perspective, allow connections to Google Drive and Amazon AWS resources and your O365. So the attacker, knowing that those resources will be available, are typically going to leverage those as part of their standard modus operandi in terms of behavior. And so it doesn't mean that anything connecting to that was bad, but you can look for the behavior going to Google Drive or an O365 or Dropbox in a certain sequence in coordination with other sort of command and control activity in order to try to say, yeah, maybe this host in our environment, even though it's connecting to a legitimate resource that's sanctioned and authorized, it seems to be matching a little bit of pattern of behavior that we should look to see, is that one also compromised in the same way. Now, we have a big challenge in terms of cryptography on the network communications. This is something that attackers are basically given the choice. You can use an unencrypted channel or you can use an encrypted channel. Which do you want? And so attackers tend to prefer to use the encrypted channel in order to protect their communication. If you did a memory extraction from the host that was compromised, you could look for cryptographic keys which are in place in that host. Just because an attacker is malicious and aggressive doesn't always mean that they're smart. And so they may be actually implementing crypto in a way that would allow you to actually retroactively decrypt communication from other hosts. Now, this can be something where it's like there may actually be a certificate that they're using for certificate pinning in the application that's running on the host. You could actually look for that certificate and certificate pinning, and then if you have something like full PCAP, go back to the network traffic that you've captured previously and look to see if other hosts are using that specific encryption and certificate in order to establish a TLS connection. And so this is something that you can look for the certificates from the server. And then, of course, we talked about this more in the first one, but the JA3 client and server handshakes would allow you to fingerprint the way that the client actually offers a negotiation as part of the TLS handshake, allowing you to uniquely identify the client that was connecting. Now, this is really powerful as well, because rather than it being specific to that one certificate, it becomes a fingerprint of sort that you can then use for all of the clients that were connecting. You could also look to see if it's using DNS over HTTPS or DNS over TLS in order to do its name resolutions. And if you don't have that, or maybe it's using a different port than is standard, but it's still encrypted, this might also be an indicator that you can then use once you've identified on the one host that you initially found was compromised to look for that behavior on other hosts within your network. Okay, so from scenario one, my recommendations, basically you can have this time-based correlation. This can be useful, right? This can be useful, but it also is something that you need to make sure that you are using time in an effective way in order to be able to say, yeah, this is the sequencing of things. And so make sure that you have good time-based reference for the events which happened, and you're constantly updating an effective timeline of what has happened so that you can actually assert, that's strange, we're seeing this here, we're seeing that there, maybe there's something that went in between there, and then you can then go and investigate for that. Additionally, when you see cloud-based resources involved in an attack, I would suggest that you don't presume that the cloud itself has been compromised. Just make sure that you're, sort of treating this in the right way. Just because the attacker is using Gmail, that may be something that is part of the intrusion, but it doesn't mean that that's necessarily bad for your entire environment. It's just that in that particular case, the adversary got control of some resources and then is leveraging them, and those are legitimate resources otherwise. Okay? So the second scenario is this idea of the attacker got in and compromised an administrative level account. So to lay the groundwork of this is kind of a fictional thing, but it makes sense in terms of operations of what people do. We've got Samantha, who's the primary for managing this set of websites, and Joe is the backup. And so Samantha's account is this ADM Sam, and Joe's account is ADM Joe. And so these two accounts are the accounts which are commonly used to log into and update things on the production web servers. Now, Joe generally doesn't do a lot of this work, but Samantha is doing stuff on those servers all the time. Now, again, Joe got compromised by a phishing email. And so the attacker, once they got in, they didn't do a lot of really obvious malicious things initially. They basically watched what Joe was doing, saw that Joe had access to various environments. They stole the SSH key from Joe's host. Now, the SSH key, of course, was encrypted when it was stored at rest, which is what we do with things that we use like that. However, Joe, after the attacker watched for a period of time, Joe had to actually use the SSH key for something else. And so the attacker was able to, through keystroke logging, actually capture that SSH key passphrase. So now the attacker has the key from disk, which is encrypted, but also the passphrase, which is used to decrypt that key. Okay. And so this reusable password is now under control of the attacker, and the attacker is able to log into things in the environment. Okay. And so this is the first part of the summary. What the attacker does next is they subtly, and this is an important part of this, is that attackers aren't always egregious and obvious with the attacks that they do. In this case, they subtly replace, or not replace, but they subtly add a little bit of content into one of the web pages. Now, there are a bunch of ads which are hosted in other environments that are referenced from within this web page. And so these different ad frames are present, and the attacker adds one. And that one that they add is actually referencing content that they host someplace. And that host is going to be delivering malicious content. And so a third party notices this particular issue, right? After it's been there for an extended period of time and has been attacking people who are browsing to the website, some third party notices this. They have some cross-site scripting, blocker, some sort of thing that says, okay, this is a problem. That entity contacts your help desk and says, hey, we noticed this weird thing from your web page. My computer said that it attacked me. Your web page is attacking me. And imagine your help desk, handling this request coming in, but they probably aren't going to understand the details of how to extract this information. And so when this was discovered and once it was verified, after it took a little while to get some traction in your environment that people were actually treating it as a legitimate report, right? They just said, okay, well, let's push this last known good. And when they pushed the last known good one, they realized that malicious advertisement is still in the one that was marked as okay. And so now it's like, uh-oh, all right, uh-oh. How did that happen? Because this was the production site and it's compromised, but the last known good site is actually compromised as well. And so what the attacker had done is they had actually pushed those changes back to the repository using Joe's credentials. Now, some of you may be thinking like that's kind of skeptical. That you're skeptical of that. That's something that wouldn't happen. I have to tell you that there are attackers who are good enough to be able to decide, hey, you know what? Well, how could I really leverage this environment to the maximum to get them to spread my malicious stuff for me, right? And then when the attack happens, it doesn't come from the attacker's resources. It comes from some legitimate resource. Okay, so this is the detail sort of thing that does happen to environments. It may not have happened to you yet, but when it does happen, you're going to be scrambling to try to figure out all of the different things that the attacker has done with the stolen credential. This stolen credential, Joe's account, has access to a tremendous amount of stuff in the environment. And that attacker could have compromised other hosts, but they also could have installed other backdoors. They could have made changes. They could have added accounts to the domain. They could have gone to the email server and read all your email, right? I mean, if this was something that, there was adequate access for that, maybe they went to another administrator using Joe's network credentials and looked to see what other administrator accounts that they could use in order to cascade through your environment to get access to worthwhile information. Okay? So if I went to Joe and said, hey, Joe, give me an inventory of every single thing that you did right over the last few weeks so that we can then separate all of your account action versus all of the things that you didn't say that you did. That's going to be really hard. I mean, I can't remember what I ate for lunch yesterday. So it's like the idea of me being able to, from a job where I'm working probably 10 hours a day, be able to enumerate every single action which I did is unreasonable. And now, what I would probably have to do is go to Joe's host and see what sort of details I can extract from the actions that he performed from there, basically using logging. The problem with logging on the compromised hosts, or they're not even compromised hosts, are they, right? It's kind of we're in a tough situation. The hosts are being affected by a compromised account. So the logging on any given host where that logged into is just going to reflect that this is Joe. And being able to differentiate that this was Joe in an authorized fashion versus Joe's account under control of the attacker is tough. And what we're gonna look at are maybe some behavioral differentiators. What does Joe normally do? This might be the conversation that I start having with you. Like, think about all the hosts that you logged into over the last 3 weeks. Well, even 3 weeks. Why am I picking 3 weeks? How do I know when this got in? So I also need to leverage my root cause timeline of when did this attack with phishing email get in, and use that as a starting point, and that's my time frame, right? And so I need to enumerate the time frame and then do a full audit of all the actions that were performed using Joe's account and do an analysis of Joe's host during that time frame in order to be able to actually extract all this information. So really, this is a thing that I have found that once you're good at detecting, once you're good at doing some initial stuff, we start to make a fundamental mistake. And the fundamental mistake is when I see something that I determine to be a problem, I stop there, right? Once you're good, you think good is good enough. Right? don't let that drive your complacence and saying, okay, well, we saw this one, so that's it. Let's wrap it up and we're done, right? So sweep enterprise assets. We frequently assume that we see everything because, and there are a lot of things here, and I just, I want you to look at this list and resolve to do better. That's what this is about, right? There's a ton of time pressure on each of us. It's really hard to find the time to do things very well. We make assumptions about the way that things are. This is human nature. We oftentimes don't have enough skill to be able to do reverse engineering and other things well. Also, our organization oftentimes is saying, hey, that's good enough. Chris, let it go. Chris, just move on. Chris, just, we're cutting that off right now. It's done. All right. Leave it alone because that's it. We didn't get there. Just forget about it. Right. And so this is a way that we are disinclined to being able to do this. And the attackers are going to abuse this for their benefit. And this is how they continue to be able to operate, is we're taking good enough and stopping there. Right? The attackers are, the initial entry, even if it's the first time that particular attacker group got in, it's probably a scout. As soon as they, identify that this is a good place to operate, they're bringing their friends. All right. So just be aware of that. Use that sort of skepticism as the way that you approach things. And with that, I'd like to turn it over to Dale.
All right, that's great. Thank you so much, Chris, for that, and thank you everyone for the hospitality and giving me this opportunity to spend a few more minutes with you to take you through an example of scoping an intrusion. And that's what we're going to do in this section. We're going to go through an example of an incident. So, really what we have is, through some various detections and some other hunting methods outlined in the first paper, in the first webcast, we've identified what appears to be an intrusion. So what we're going to try to do at this point is we're going to try to scope, or we're going to try to frame that to try to get some more information around it, to figure out, what the scope, what the blast range is, where we need to focus our time, see if we can put a bit of a story together. I'm going to be going through several of the attributes that Chris covered in his portion of the talk, but not all of them. It's more along a single narrative that is sort of taking us from beginning to end, right? So we're going to have aspects of it that are going to be command and control. We're also going to have aspects that are internal movement. And so our goal for today is just to show you a bit of a scoping path along the way to see what's happening throughout the course, or throughout the lifetime of this incident. Now, a couple things to point out as our starting point. Yes, we're starting with some of the methods highlighted in the first paper. I hate doing redacting. I love real data, but then when a screen is just full of blacked out lines, it's really hard to follow. So in this case, we're using a cyber range to capture this data. One of the unique things about this cyber range, and it's something that you're going to need to pay attention to in some of the addressing. So I just want to point out very quick, if you just keep an eye on the third octet, 10.250.50 or 10.250.100 in this, these are our internal networks. So these are the portions that we're dealing with as we'll call inside the enterprise. And external is, of course, anything non-RFC 1918, as well as 10.250.20. So our initial host of interest is a host I'm just going to call the victim. It's easier just to use terminology as victim as attacker. It's very easy for me after the fact to go through and put labels on these. So we're just going to start right off the bat, putting these labels of victim and attacker on it. And our victim, or initial host of interest, is 10.250.50.117. So with that, let's jump into it. Let's begin our scope. And we're going to start with some information. Of course, as I mentioned, we've had some various detections along the way. We know there's an incident. Now we need to get our head around it, and we need to figure out what's happening. One of the earliest pieces of information we found was this C2, or this beacon that was presenting. Now we covered this in the last one for the threat hunting. Chris went through this again, and this is some evidence that we're seeing by using the network metadata. We're seeing that our internal host, our victim, is communicating with an external host, our attacker. And this case, it's over HTTP. What we can see is that this, through the metadata, is a single response, multiple session. So, there are different ways. Chris mentioned it. They could be, domain fronting. They could be multi-hosting. They could be doing all kinds of things. In this case, it does look like it is a single asset or entity. There's nothing saying that's not load balanced on the back end, but as far as we're concerned, we're dealing with a single entity. Externally, we're dealing with HTTP, and we're dealing with session counts, thousands of session counts, with some moderate duration and relatively consistent response bytes. Now that's all we know at this point, right? We just know, hey, this thing sure looks like a beacon. We know our victim's talking to our attacker. Let's see what more we can figure out. And this is kind of our jumping off point of the earliest piece of information that we have. So next, what I want to do to start framing this, I want to get a better idea of the external connections. Now, of course, this is going to be pages and pages of material. What I've done is I've sorted by first communication, sorted by IP, so that we can take a look over time by the connection timestamp, so we can get an idea of who's talking to who. And of course, lo and behold, what else comes up for that same attacker? We're seeing not just port 80 connections or HTTP, we're also seeing 443. Or SSL HTTPS connections. We're also seeing port 22. We're seeing bytes sent, significant number of bytes sent. We see several other hosts as well. As I mentioned, this could be pages long. Some of it look, pretty standard type, assets.msn. There's going to be lots of stuff in there. So this isn't my be all and end all, but what I want to do is I want to get a list of, okay, where am I communicating externally within this time frame that I'm interested in, and where am I jumping off points? That's the external side. I also want to look at the internal side. And on the internal side, I can see my internal connections. And there's lots and lots of connections here as well. I expect to have a lot of internal communications. Again, a similar type sort going through who am I speaking to internally in the environment and what kinds of protocols am I using. So, we can sort of summarize a long list into some common, living off the land or ubiquitous protocols. Things I would totally expect inside my environment. I see my victim as communicating to several targets inside using LDAP, RPC, SMB, RDP, DNS, the list goes on and on. I totally expect this. Now, just because it is expected doesn't mean that it's good, but also it doesn't mean that it's all bad either. So we need to go ahead and we need to figure out how to frame this even more. So let's continue on down that path of trying to scope this. So what I'm going to start with when we sort of reverse back on that timeline, I'm going to start at this, what we're calling, this command and control, this external HTTP. And if you go back to our beacon, and we want to take a deeper look into that. So now what we're doing here is we're exposing the network metadata for this HTTP communication between our victim and what we're calling our attacker. And by using it, what I can see is there's primarily gets, there's also posts in communication from in to out. And I can see a commonality of these URIs in the bottom left, you can see in the green, and as well as in the URI in the middle of the screen, login, process PHP, admin PHP. Google's our friend. We do a search on Google and, this thing looks and smells like PowerShell Empire. Attackers are lazy. These are the defaults in it. It doesn't matter if you change the defaults, that beacon is still going to present. There's still going to be commonality. I change URI all the time to look like certificate revocation lists and stuff like that, make it look like PKI, make it look like totally normal checks, but it's still going to present in a similar fashion, get, posting, so, a finite number of URIs repetitively being used. Fortunately, in our case, we're able to, attribute it or believe we've attributed this to PowerShell Empire, which is, I want to really go deep at this stage, but I really have to hold back because, the worst thing you can do is start pulling a thread, go in the wrong direction and go in the wrong direction for too long and then get back to, what Chris was talking about. Sorry, you're out of time. Close it up. I want to be able to do a larger scope and I want to keep peeling that onion and I want to make sure I go in the right direction, bringing it in. So I'm continuing on. So I've also, if you remember back from our time series, I was also communicating over 443. So I want to take a deeper look into that traffic as well. So see if I can get some more information. And in this case, in the first block of evidence, what we're seeing is we're seeing an in to out connection. We're seeing 443. We know that it's TLS12. These are the JA3 hashes that Chris was talking about. We want to grab that information. I also want to take a look at the certificate. And I can see that the certificate being used in this case is a self-signed or self-issued certificate with this jones.suns.io. Self-signed, I can look it up all I want. I'm not going to get any information on that. That's a dummy self-signed certificate. But there is something I can do with this. I can look up those JA3 hashes and I can see that there's some attribution, that hash, and Metasploit. So I'm not 100% sure at this point. There is a likelihood that this encrypted command and control channel is Metasploit. So far, we've got this, beacon happening to the outside world over HTTP. We're communicating several protocols to an external host, one or more. We've got our internal communications, and we have what looks like two control channels being presented, one over HTTP and one over HTTPS. So, okay, likely I'm being controlled from the outside. What's happening? So in this case, what we're seeing next in the time series is we're having, we're just calling it a port scan. Now, one of the easiest ways to find port scans in network metadata is looking for 0-byte connects. These things might connect completely with a full TCP, SYN, SYN, ACK, three-way handshake. But in my list here, I can see that summarized, there's two hosts, .62 and .99, that are being targeted. And I've got over 5,000 counts of 0-byte connects to those. Now, I know those devices. Those are two of my servers in my environment. And if I look at the other chart to the right of it, this is just a descending list of ports. The first column is the port. Port number 1, port number 7, port number 8. There's multiple pages of this because there's counts. There's 5,000, 10,000 of these things going on, and it's going through the list. Now, when I summarize that list, I can see that it's trying to connect to ports 1 through 1024. My victim, .117, is trying to connect to ports 1 to 1024, as well as 1433 SQL, as well as 3389 RDP in the high-level ports to two of my servers. So I find that interesting. It's definitely a port scan of sorts that's happening. And so next in the time series, what I'm seeing is what we're calling an account scan. So when I'm going into the NTLM metadata that is being captured for this, I can see that my victim is speaking in to three entities. In this case, they turn out to be my file server, my domain controller, my application server. And what they're doing is they're presenting several usernames, null, administrator, demo. You see a partial list on the far right there. And they're presenting it all under domain credentials. And success equals false if you look at the last column in the middle. So they're not successful in using those accounts. I don't even use a number of those accounts in my environment. And that's why I'm calling it an account scan rather than maybe something like a brute force, because they're just trying to see if any of these accounts exist in the environment. Maybe they're left to the defaults. I'm a little smarter than that, so I've made these protections inside my environment. But it doesn't mean that they didn't try to do an account scan, and that's certainly what that looks like. And so next I see some more reconnaissance. And in this case, it's RDP, and the targeted devices, in this case, when I summarize, are my file server and my application server. Now, this is encrypted RDP. By default, most RDP is encrypted, but there's still information that presents inside of it. The cookie includes the username. Sometimes you'll get these different client builds to see maybe a certain type of client is used. But in the green box on the side, I can see that there are several cookies or accounts being presented, and those accounts look like default accounts, VPN, remote access, remote. Looks like guesswork here. Looks like my victim is trying to contact and determine if any of these common RDP or remote accounts exist on these what are going to be RDP-enabled devices, because RDP is so ubiquitous. So I see what I'm calling this internal RDP recon happening next in the time series. So we're still end-to-end. There's still a lot of stuff happening here. And on the end-to-end, we're also seeing this brute force attempt. Now, how do we know it's a brute force attempt? What we're seeing is we're seeing communications from our victim to those two servers from the previous one, .99 and .62, my application, my file server. And what I'm seeing is I'm seeing relatively stable original sending IP bytes and responding IP bytes. And I've got pages and pages and pages of this. So this trying repetitively, and the duration is very short, right? These are all in milliseconds. So that's telling me that I'm trying to connect. I'm establishing a connection over 3389. I'm sending and receiving bytes, so I know I've got some level of connection, but it looks like I'm being turned away. Otherwise, what would I expect to see? Well, longer duration. You know, if I be able to connect in, I'm going to paint my screen or something. I'm going to have more duration and I'm going to have more bytes. So it doesn't look like they're successful. I don't know for sure, but it looks like they're certainly trying repeatedly to access over RDP some of my servers. So I'm including that as part of my scope and my timeline. Now, the next thing that I'm seeing here is this SQL injection. This one's very clear. This is an in-to-in. We take care of all our crypto, you know, at our perimeter of where these applications are, and we do a lot of offloading with it. So now it's in this protected area where I am seeing clear text and I'm seeing HTTP into my SQL server. I can see through the, you know, the bar there in the middle, the testing ASP 1 = 1. Here, SQL injection. I can also see from my status message that it's not found or didn't succeed. You know, we try our best to lock down and protect our assets from, you know, common attacks like this. Again, it doesn't mean an attacker is not going to try. Certainly, if they can, you know, get access to it and dump all the data from there, you know, they're, you know, so much further ahead. So it looks like it's just an attempt from my victim targeting my application server where my SQL database is running. How did they pick that up? Likely in the port scan, finding out, well, who's running 1433, so they know where to attack. And I can sort of historically sort of go back and piece some of the stuff together to say, well, how do they know to go here? Well, they got that from a previous step. And like Chris was mentioning, there's no such thing as a one and done. You know, everything that you're doing is a progression. It's leading to something else. I need to gather some piece of information or attempt, whether it's positive or negative, in order so that I can go on to the next step. And so the next step on the time series in this case is another reconnaissance. Now, there's a theme here. There's a lot of reconnaissance. The least interested of reconnaissance that I'm interested in is that port scan. You know, I'm more interested in that SMB account scanning. I'm interested in that RDP account scanning. I'm interested in them, you know, just trying and testing my SQL. I'm interested in this LDAP scan. Now, what I can see from this LDAP scan, my victim communicated with my domain controller over LDAP. Easy enough to find. My victim is part of the domain, so that's easy. And in the yellow block in the middle, I can see the query that was made. The query, if you look at the very end of it, you see admin count = 1. So pretty astute. This attacker isn't dumping large volumes of content, not dumping every computer in the environment, not dumping every user account in the environment, is being very selective. So if I'm looking at anything from a byte or a volumetric perspective, then I'm likely going to miss this in entirety because it's not very big. But what did they do? They did dump who are the administrative groups and who are the administrative users. And you can see, you know, by the power of retrospective analysis, and, you know, spoiler alert, you'll see this coming in the future, one of the accounts that they were able to identify that had administrative privileges was this Lanacane admin. So I know that this device, this victim, knows what administrative accounts exist inside the environment. This is very clear. They've been able to garner that information and gather it. So that's part of my scope. They've been able to inventory the administrator, users, and groups, and trying to do it a little bit under the radar, if you will. So here we're going on to, again, more reconnaissance, RPC, living off the land. So what I found in this area is on the graphic in the left, I can see a list of hosts that have been targeted. And it's a finite list, you know, kind of working in chunks. So I've been able to sort of summarize those to a number or finite number of assets. Now, what happened in that case is I can see the RPC calls that were made to each of those hosts. Those RPC calls are listed here. The SAM connects, the SAM close, the SAM open. Again, Google's my friend. I want to go and Google those things and I want to find out. And one of the things that I find is there's a commonality between those, that looks like Sharphound. And so if you're familiar with Bloodhound or Sharphound, now this makes sense to me. This makes a lot of sense because if I'm trying to find administrative accounts, I know, and I now know that my victim knows that Elkane is an admin. I now need to find where is Elkane operating. I can't just go and try, you know, 10,000 different machines. I need to move, you know, programmatically to you know, specific machines. So I want to find out where these accounts are running. And it may not be just Elkane. That might be a red herring. You know, there might be other accounts as well. But I can see it makes a lot of sense that using RPC calls, trying to determine, or using tools like Sharphound that just run RPC calls to be able to say, hey, who's running, what accounts are running on each of these devices? Because I'm very interested to find out where those accounts are running. So next, we'll continue with our end-to-end. End-to-end, it can continue for a very long time. There's a lot of activity that needs to be done. So here we're seeing what I'm calling local administrator validation. Now, how do I know that? Well, I know that by piecing the data together. What do I know? I know that my victim spoke to a number of hosts. So I've got these hosts, .34 to .44. I know it spoke to those. I got records for each of those with my network metadata connections. I know it's over SMB. I've got all the SMB metadata that's happening over the network, that communications. I know that the victim sent the same payload or similar payload. Now, again, I don't know what's inside that payload itself, but what do I know? I know that each connection from victim to target, we'll call it target 34, target 35, etc., used SMB. I know that they were all 585 bytes in send and 909 bytes in receive. They're all very similar. Now I want to dig deeper into the SMB traffic to see what else I can find. And what else I can find is that there were connections to each of those machines that utilized the NTLM username administrator, and a success is true. We do use the local administrator account to manage all of our machines. This isn't a domain administrator. This is a local administrator that is local to the account, but it's how we do all our patching. It's how we do all our updating. And so I know now that my victim is able to communicate with each of these targets over that local account. So gathered some more information and have proven some more scoping details. Time series wise, we're looking along, and the next thing we're seeing are these additional SMB connections from victim to workstation. And so on the time series, and these are a little larger and whatnot, and it's not part of that SMB authentication, what we're seeing, connections again to all those hosts, those same hosts. We can see in the SMB share data that there are local shares. We have several local shares on our workstations we use for patching, performance logs, SECM. Of course, you've got your admin dollar, your IPC dollar, all the shares that belong to each of these workstations anyway. We see that those shares are going back to the victim. So the successful enumeration of those. And, after a bit of heavy lifting and a comparison and stuff, one of them, and retrospective analysis as well, we see there was an extra share that was presented back to the victim, and that's this Elkane admin. Now remember, we saw Elkane admin earlier when we're going through that LDAP enumeration, so we know that this is a piece of information that is valuable to our attacker, and we can see that they've kind of enumerated this workstation or several workstations, and they've been able to pick out one that is very interesting, at least to them. And so now lateral movement is what we're seeing. We're seeing a remote execution is the next thing on that time series that we see. We can see that the victim spoke over SMB, right? Communicated with 42, that Elkane machine. We see that. We see that that SMB traffic was actually RPC over SMB. And inside that RPC metadata, we can see that it was all service control as the endpoint, and the operations were, well, open the service control manager, start a service. The service, when it starts, does its job, deletes the service, closes the service, and it's done. Subsequently, what we end up seeing, and you can see by the timestamp, afterwards, there's a rest period. Very smart to do a bit of a rest period, because now we're going to look at a wider time range. We can see that for 42, that Elkane machine called out over port 4444, an outbound call, using an unknown service, likely encrypted over a non-standard port, communicating to that same attacker, to that 117. And we can see the duration in milliseconds. We've got a number of packets sent, a number of packets received. So, okay, my scope continues to get larger. I definitely have another connection in here that I gotta fight the urge to go down that path and pull that thread, because I can get stuck in there forever. What I'm trying to do at this stage is I'm just trying to get the frame around the entire scope of the problem so that I can take the next appropriate right steps. And so that was the remote execution. Now we're seeing an SMB brute force. Now, how do we know it's a brute force? Well, here we're looking at connectivity, again, SMB from victim to internal target into in. We can see that it's SMB communications. We can see that the username presenting is Elkane admin. We can see the domain presenting is blank. What does that tell me? Local account. That's not a domain account. I've got hundreds or thousands of records where the success is false. The top record that I can see is true. So after, in a time series, lots and lots and lots of false, I see a success. My victim can communicate with Elkane using a local Elkane admin account. So the next thing I see is another lateral movement reading a password file. So in the top part, I know my victim communicated with Elkane. I know they connected to a share, the share they found earlier, Elkane admin. I know that they opened, read, and closed a file called passwords.txt. Now this one is very in your face. It's not like it's uncommon. It's actually way more common than everyone expects. But the interesting part here is going to look through what files were accessed. There were other files that were accessed. This one, of course, was very interesting to me. So I wanted to take a look into it and to see, okay, well, what are you doing within the scope of this file? So we know we've been able to access, very sensitive file. And then the next thing we see in the time series, our victim connected to my file server, .99, left Elkane, connected to my file server, used an account in the domain called backups, and enumerated all of those disk shares. And so going back in time and looking at my passwords file, fortunately, Elkane, it wasn't domain admins. Like, it wasn't as ridiculous or stupid as like putting a domain admin account in there, but Elkane is one of my backup administrators. And there was a backups account, a backup service account that was in that passwords file. So, maybe they could have got it from Mimikatz, they could have got it from some other way, but certainly that password and that account was available from our victim or attacker through our victim pivoting to our file server to enumerate the shares. And then the next thing we see, there's our connection to a sensitive share on our file server, the mission share over SMB version 2. There was several files read. There's pages and pages of this stuff, and they consume a lot of records. Sorry for the duplicate entry there. I just showed one file there. But I can see that the victim pulled what we call a data gather over SMB. SMB copied, in this case, 3 gig of files from the file server to the victim. So they copied it locally. That's why I'm calling it a data gathering or a staging event. And then subsequently, we saw an action on objective where we see 3 gig plus roughly the same size and shape of files that were just gathered to the victim from the file server. We see the victim pushing that out over 22, over SSH, to our attacker. We can also see in the metadata, we get the SSH hashes. We can also see that it was a PuTTY client that was utilized. And sorry for the graphic at the bottom, that should be SSH copy at the bottom, not SH. But we get an idea of, okay, how they got the data out. Now, that's the end of this story. I know I promised you like a full scoping and stuff. This is only the first scope. I still have a lot of work to do after this, but at least I've framed it. I got to go into Elkane. I got to see who else is communicating with the end. I got to do some more investigation on my workstations to see if any other remote staging code has been loaded and that type of thing. But I've been able to piece together. I know the data that's been compromised. I know the key participants, and I can use that to frame the rest of my scoping and the rest of the work that I have to do. And with that, I just want to, let you know that if you're interested in exploring this any further, we do a lot of hands-on activities to go through scenarios like this. You can join the next workshop. Check out our website, Vectra AI/events. You can earn CPE credits and sharpen your skills on both the attacker and defender side and run through some of these examples. At that, I've robbed you of most of your time. I'll turn it back to Carol, see if we have any time for questions. And then thank you.
Thank you, Dale. That's great.
All right. Thank you, everyone, for that great presentation. We do have some questions ready for the Q&A. However, if anyone has a question for our presenters, please enter it into the question window now. You got a compliment. Someone says you're doing very well with this talk. All right. So The next question says, for the last 3 slides, is the attacker working manually? Will the same methodology reveal automated exfil?
Yeah, the same methodology is certainly gonna pull it together. We see a lot of manual when they're being very surgical. You know, when they're trying, when they've got things are very specific about. Sometimes, what we would see instead of a data gathering, you would see maybe something more like a smash and grab, a lot of volumetric stuff. And so whether you're doing it through automation, smash and grab, or you're doing it through very tactical, very surgical, the same concepts are going to present. And so really you just want to pay attention to what type of data is transferring, the rate it's transferring, and certainly a source of materials.
All right, thanks. The next one asks, how does this help me clean up the infected endpoints?
Yes, that's an awesome question and I left it at that. Our work isn't done here, and your next step is moving on to those endpoints, and there's a couple ways to do it. Certainly at Vectra, we integrate with the endpoints, and integration is more than just response. Yeah, I might want to lock down some of these endpoints as I'm doing this investigation, as I was going, and at least to buy me some time to stop the bleeding. And then there's also the enrichment side, and that's basically pulling in the data so that I've got more information at my fingertips. I don't have to hop all over the place. So what is my endpoint telling me? What services are running? What's the host? What kind of endpoint is it running? We want to enrich. What's its name? Like, I've used a lot of IP addresses here, but I like to work with the names. So I like to enrich it with the data. So at this point, yeah, I want to integrate with several. We've got like over 10 EDRs. You name an EDR, we can integrate with them to either enrich with data or enforce the blocking. And now buy yourself some time, move on to the endpoint, and peel that onion and try to resist the urge to dive in and pull every thread at once, and try to be programmatic at the way you do that.
Yeah, and if I can just add on to that in terms of the point of the scoping is you want the attackers out, right? Part of, as soon as you start interacting with the attacker, they're going to respond to that. So you need to decide to contain actions, you need to decide on your containment actions. So things like this, this individual IP address which is identified, I would want to block that very, very quickly. The LCAN admin account, I would want to suspend that very quickly. Like, all these things that I know are problematic, but that's not the end. Like, changing the password on the LCAN admin account isn't going to solve this problem. The attacker's in and operating. They have credentials. They have the backup credential. They have all these different things in your environment. You need to find everything that they have in your environment. And then after you have, temporarily stopped them and continued to find everything that they've been able to do successfully in your environment, you then need to dismantle their infrastructure, which is present in your environment. And as Dale has said multiple times, like, this is what he's doing, where he keeps sort of saying, okay, I want to go down this more, but I also need to go over here. So that might be a containment action that happens at that point. You need to be ready for these things, where it's like, I have at my disposal the ability to block in a web proxy, the ability to block on a firewall, the ability to suspend accounts, the ability to do all these different things. Understand what your repertoire is in terms of containment, and trigger those actions. And then at the end say, okay, here are all the things that we did in an immediate responsive action. Let's also make sure that we clean this up in the long term, but we don't make the mistake of saying, okay, well, we contain, let's just eradicate, and now we're done. Because if you do that prematurely and say that you've eradicated all this stuff without doing this extensive inspection, then the attacker is going to be right back, and you're going to be chasing them into other places, and they're going to adapt and be better because they know that you're onto them, and so they're going to learn from you in terms of how much you have in terms of knowledge of their behavior, and then deviate from what you have caught them on previously and shift methodology. This is the idea of scoping. We need to make sure that we get a thorough and complete picture of what's happening. So sorry, Dale, I didn't mean to cut you off there.
Oh, perfect.
All right, well, with that, we're out of time. Thank you so much, Chris and Dale, for your great presentations, and to Vectra for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.
Great. Thank you.
Thank you.